So for our final example on solving our equations with algebraic fractions, let's have a look at this particular equation. We have 2a minus 1 on 3 minus 3a minus 2 on 2 is equal to negative 7. Okay, first thing, common denominators. All right, so we've got a denominator of 3, we've got a denominator of 2. We also have a denominator of 1. Okay, so negative 7 is really just negative 7 over 1. All right, so let's use common denominators of 6. So in order for that 3 to become 6, we can multiply that, for the first fraction, the whole thing top and bottom by 2. This fraction, we multiply top and bottom by 3. And this, well, I'll kind of call it a fraction, but this whole number, top and bottom by 6. Okay, so what we end up with is 2 outside of 2a minus 1 on 6 minus 3 outside of 3a minus 2 on 6 is equal to negative 42 on 6. Okay. Now that all the denominators are identical, we can in fact cross them off, so we don't actually need them. Let's expand now the brackets and form our equation, our simplified equation, and hopefully get to a solution. Okay, so 2 outside of 2a minus 1, you've got 4a minus 2. Okay, now this is where it gets quite interesting. With fractions, and this is one of the differences between fractions and division, even though they're practically identical, but this minus here is subtracting the entire numerator. Okay, so I'm going to put a minus and then open bracket. 3 outside of 3a minus 2, that's going to be 9a minus 6. Okay, so this numerator here is 9a minus 6, but then you have a negative in front of all of that. Okay, so fractions have implied brackets basically outside the numerators and denominators. So there's sort of an implied bracket there, which we don't always show. And that's equal to negative 42. Okay, so next line, we have 4a minus 2 minus 9a plus 6 is equal to negative 42. Okay, so far so good. 4a minus 9a, we've got negative 5a. Okay, is equal to negative 42. We're going to add 2 and then subtract 6. Okay, so that goes and that goes. And negative 40, so negative 40 minus 6, negative 40, negative 46. Yep, I think we're happy there. Now you can see that there's a negative on both sides. So the negatives, with the negative on both sides, really sort of becomes positive because you can cancel the negatives out and multiply by negative 1. But we're not going to do that. We're just going to divide both sides by negative 5. Negative 46 over negative 5. And really that's just the same as a is equal to 46 over 5. Okay, or that's 9 1/5. Okay, it doesn't really matter. I'm happy to just keep it in improper fraction form if you like. So make sure you also test that. Make sure that left-hand side equals right-hand side. If you remember, hopefully this you can see that. We can test that answer. So I'm going to I'll do this as quickly as possible. 46 over 5. Okay, we're going to store that. So shift STO. Okay, we're going to store that in this memory location A. Okay, till you get a 46 on 5 with an arrow pointing to A. And then what we're going to do is we're going to type in the left-hand side. Hopefully we'll get negative 7. So let's just see if that's in fact the case. So let's type it out. We press the alpha key to type in the pronumerals. Okay, minus 1 over 3 minus, and fraction button there, 3a. Okay, minus 2 over 2. And no surprises there, we get negative 7. So I think we're reasonably satisfied that a equaling 46 on 5 is the solution to this equation.